Okay, we just finished talking about a previous video where we looked at some properties of sine and cosine curves, otherwise known as sinusoidal curves. Um, but in this one, we're going to look at some of the effects of when we change the equation of a sinusoidal curve and what happens to it with regards to horizontal and vertical shifts. So horizontal being side-to-side shifts, vertical meaning up and down shifts of that curve, and the amplitude, which is meaning how high up and down that curve goes. The higher the amplitude, the further up and down it will go. So we're just going to look at that with respect to these equations. When you see an equation like this, first of all, the amplitude, it's kind of handy that it starts with a, because that a is the very first number you see, or the coefficient in front of sine x. So if you were to put a 2 there, and a sine x, instead of it being a regular sine curve like this, the 2 would double. It used to go 1 and down to -1. The curve is actually going to be stretched, and it's going to go up to 2 and down to 2, because if you remember from the last video, the amplitude is the distance between the median, or the axis of the curve, which is this line here. It doesn't have to be the x-axis, but it's the line that slices through a sinusoidal curve horizontally. This vertical line, the distance between that and the maximum, is our amplitude. So that changes, and it becomes bigger when you have a 2 in the front. Okay? If you make things more complicated, and if you write a 2 there, but then you put brackets here and you have x minus 5 and then on the end plus 3, if you do that, well, that 2 is our amplitude. This 5, it's just like dealing with quadratics, okay? It's just like dealing with parabolas when you have an equation. The brackets, they always lie to us, if you remember that from quadratics, okay? From parabolas, the brackets always lie to us. So this -5 is actually going to shift our parabola. It's called a phase shift. It's going to shift it 5 to the right. Okay, it's going to shift it 5 to the right, not 5 to the left like you might have guessed. The 3 on the end is going to take this parabola, it's going to take a parabola, and it will also take a sine curve like this and move it up 3. Okay? I hear Star Wars music in the background because it's May the 4th here in Canada. Interesting. It's also Cinco de Mayo, for those of you that know what that is. Okay, anyway, so that 3 causes the vertical shift. Okay, the vertical shift. The 5, which is also that h value right there, just like the 3 was the k value, that's the horizontal shift. Okay, sometimes it's called a phase shift. I'll write phase there for you, phase shift. I have no idea why it's called that, but horizontal shift is really the language that's easier to remember. Phase shift is also used, though, sometimes in textbooks. 2 is the amplitude. It's at the very front. Those are the 3 things from this video you need to know. Let's check it out using Desmos, okay? So I'm going to push pause here and get Desmos going, the graphing calculator. Okay, so here we have Desmos. Now to set things up, I'm going to start from scratch. I know that you can't quite see what I'm talking about, but you're going to click the wrench icon right in this corner. It's the graph settings. And let's change it to degrees right now. Okay, and let's change our x-axis from 0 to 360 degrees. Okay, and that's about all you need to do. I'll put it on projector mode just to make it easier to see. Okay, all right, so let's type it in. Y equals sine x right now. Look at that. Immediately we have a nice sine curve. Notice 1, 1, 2, 3, 4, 5. Those are the 5 key points that I was talking about earlier in another video. And in case you can't see them all, oh, I guess I move the graph and they disappear. Oh well. Anyway, they come back for just as quickly when you touch on the graph with your mouse. Now, this Desmos app that you're looking at is free. It can be used on your phone or just use it on a computer. It's all free. I would never tell you anything that costs money. Okay, let's do things to this sine curve. Remember I said about the 2, how it would start to go from, I was hoping we could see. Well, you can tell this is going a maximum of 1, and I guess I'm going to keep that out like that. Sorry for this. There we go. So the maximum is 1, and the minimum is -1. So let's change this to 2, and let's see what happens. Look what just happened. The maximum is now 2. The minimum is also now -2. If you were to put a negative sign in the front, just like a parabola, it would flip this sinusoidal curve upside down. See what happened? It flipped it upside down. The cool thing about Desmos is you can type in a letter. So you can type in, just want to make sure that phone call wasn't for me. It was not. I'm going to hit the letter A there, for example, instead of the number 2. It says, would you like to add a slider? Yes, please. Now, I can take this and show you how the parabola stretches, because A is stretching. Whatever this slider is what A is. And see how it's stretching? And A is going to become negative, flip upside down. Pretty cool, hey? This could not be done when I was a student. My teacher had to draw this on a chalkboard, and that was it. Boy, things have changed. Okay, so let's keep it at just sine x there. And let's do more to this parabola that we just talked about. Do you remember what if we put brackets here with the x on the inside, remember I put an x minus 5. All that did was it shifted this sine curve. I don't know if I said parabola earlier by accident. It shifts it over 5 to the right. Okay? It cuts through now at 5. It no longer cuts through at 0 like it used to. This part here is now cutting through at 5, or 5 degrees. Okay? So everything has shifted 5 to the right. If I put a plus sign here, it does the opposite of what you think, because the brackets lie to us, and it shifts 5 to the left. What I'm going to do is put a letter here, the letter H, and put a slider, and just show you this parabola sliding left and right. You see that? Okay. It's not very dramatic, is it? The cool thing with Desmos 2 is I can change these numbers so that it goes to like -100 and +100. And I think that'll work. Let's see what happens here now. See that? It's going 100 to the right and 100 to the left. Notice 100 to the right brings us right to this spot. That's where sine normally went up. But sine used to go up right there on the y-axis. That's where it was, and we move it 100 to the right, and that's where it starts now, right here. It starts climbing right here. Anyway, hopefully that's a good enough explanation for you there. So that's what a value will do inside the brackets. Okay. Now let's just put a number on the end, like +2. And do you remember what's going to happen if we do that? That takes the parabola and it cuts through at 2. When x is 2, I'll just type that in, or sorry, when y is equal to 2, that is called the median, or the equation of the axis. The axis of the curve, as some textbooks talk about. It's just the orange line there that's cutting through this sinusoidal curve right in the middle. Okay. Now the amplitude is the distance between this orange line and the maximum, okay, which is at 3. We know this is at 2 and this is at 3, so the amplitude is 1. Again, if I change the amplitude to 2, it makes this amplitude from the orange line to the maximum here 2, right? From 2 to 4 is 2. Okay, no matter where you go on this line, it's too high. Okay. I hope that's enough basic information just on the properties of a parabola when it comes to the amplitude, the phase shift, left and right, as well as the vertical displacement or the vertical shift up and down. If you put a -2, it's going to go down 2. And I didn't actually show you what to do if we had a slider on there, so let's do that just for fun. I'm going to call it K, and let's just make a slider. See that? It goes up and down. I totally recommend you fooling around in Desmos here just so you get really comfortable with this, because the more comfortable you are, the more this will just be fun and games for you. Okay? Thank you.